In the E2 reaction, the three events, proton abstraction, formation of a carbon-carbon double bond, and departure of the leaving group take place at the same time. What if these three steps do not take place at the same time? What kind of elimination mechanism we will get? Let's see how these steps can be separated. So this is the general structure of a substrate or an alkyl halide with a leaving group. As in the SN1 mechanism, the first step would be for the leaving group to leave, and if the leaving group leaves, then a carbocation intermediate forms. So this carbocation is then formed. In this case, this carbocation is formed. And then a base will come in now. A base will come in now to remove a hydrogen from a nearby carbon, nearby to the positively charged carbon in the electrophilic carbocation. So the base will now come, and take off this proton, and with simultaneous formation of the carbon-carbon double bond. So this product is then obtained. Plus, of course, BH plus L minus as usual. So BH again is the conjugate acid of the base that is used. L minus is the leaving group. It could be the halide if we talk about alkyl halide. So the point here is that this step, which is departure of the leaving group, is what takes place first. So the departure of the leaving group takes place first, then which would then lead to a formation of a carbocation, and then proton abstraction and the formation of the carbon-carbon double bond. These two steps now take place at the same time. So this is proton abstraction, and here is the formation of the carbon-carbon double bond. So step one would be this departure of the leaving group. Step two would be proton abstraction and formation of the carbon-carbon double bond. So therefore, this is not a one-step elimination. It's at least two-step elimination. If it's two-step elimination, then the kinetics will be first order. So therefore, in an analogous way to E2, the type of mechanism here should be E1. E for elimination, 1 for unimolecular or first order. So this could refer to unimolecular elimination mechanism. It is also first order because the rate of the reaction now, this is also similar to SN1, by the way. The rate will depend on the concentration of only the substrate or the alkyl halide, because that's what happens first is departure of the leaving group. So the concentration of the substrate here is more important, and this is what determines the rate of the reaction. Step one is the rate determining step. In this reaction, this is the step that determines the rate. The rate depends on the concentration of the alkyl halide. So therefore, it is first order kinetics. First order kinetics. Now, since the E1 mechanism, just like the SN1 mechanism, proceed through a carbon-cation intermediate, therefore the base here does not have to be strong. The base in E1 reactions doesn't have to be strong. Why? Because the base is going to react now with an already highly electrophilic carbon-cation intermediate. This is also similar to SN1 reactions. The nucleophile in SN1 reactions should not be strong, because in SN1 reactions, the nucleophile reacts with an already electrophilic carbocation intermediate. The same thing here, the base reacts with an already electrophilic carbocation intermediate, so the base doesn't have to be strong, so neutral base will do. So neutral base is okay in this case, and neutral bases are examples are water and alcohol. So basically an organic base with a lone pair. So these are examples of weak bases that could take part in E1 reactions. Yeah. Okay, so the base doesn't have to be strong because this is already electrophilic intermediate. This is highly electrophilic, and that's why the base doesn't have to be strong. Okay, the base doesn't have to be strong, and that's why neutral bases or weakly basic reagents will be able to take part in this reaction. So the base should be of that category, weak reagents. Yeah. Okay. The E1 reaction consists of two steps. It is first order kinetics, and the last piece of information here is the energy diagram. Okay. Since there are now intermediates, then there should be at least one minimum between the reactants and the product. So an energy diagram for this type of reaction, should be something like that. Yeah. So reactants here, products here, two transition states and one intermediate. So there is an intermediate here, of course, which is the carbocation intermediate. So that minimum must be shown in the energy diagram. So this is an energy diagram that is suitable for not only E1, as in this case, but also SN1, because both mechanisms go through carbocation intermediates. Both mechanisms, E1 and SN1 reactions, go through carbocation intermediates, so this energy diagram, therefore, is suitable to represent them. A last piece of information is that these weak bases now, which are suitable for the E1 reaction, by the way, can also do SN1. And this is very, very important, is that weak bases are also weak in nucleophiles. So weak bases cannot only do E1, they can actually do SN1. So the weak base, okay, weak bases will do E1 and SN1 at the same time. So it's not surprising to get a mixture of a substitution product and an elimination product if a tertiary alkyl halide is treated with a neutral nucleophile or a weak base. Yeah. So this is an example of that. So let me give you an example of what that means. If we have this alkyl bromide and we treat this with water, for example, yeah, we treat this with water. Okay, so the alkyl bromide can lead to a SN1 product and E1 product. So this product could be obtained, which is an SN1. This is the SN1 product, and also the E1 product, which is this one. So this is the E1 product, and this is the SN1 product. In this case, the alkyl halide led to a mixture of substitution and elimination products. That's because the alkyl halide is tertiary, and also water is a weak base, and also it is a weak nucleophile. A weak base or a nucleophile can lead to a mixture of SN1 and E1 product. The last piece of information here in this discussion of the E1 reaction is the suitability of substrates for E1. Now, since the E1 mechanism of the E1 reaction proceeded through carbocation intermediate, then substrates that can lead to stable carbocation intermediates will be the most reactive. So therefore, tertiary alkyl halides, X or L, by the way, it doesn't really matter. Tertiary alkyl halides will be very reactive in the E1 reaction. They'll be very suitable, followed by the secondary alkyl halides. When then we add to them benzylic substrates, if you remember, benzylic substrate and also allylic substrates. So these are the most suitable tertiary, followed by secondary. So this is a tertiary alkyl halide. This is a secondary alkyl halide. This is a benzylic halide, and this is allylic, halide. So these are the most reactive. These are the most reactive substrates in E1 reactions. Tertiary alkyl halides or tertiary substrates are the most reactive in E1 reactions, followed by the secondary alkyl halides, and similar to benzylic and allylic alkyl halides. Primary alkyl halides are the least reactive in this case. So to conclude this lecture on E1 mechanism, the E1 mechanism is a two-step elimination. It's a two-step elimination. Step one involves the departure of the leaving group to form a carbocation. Step two involves proton abstraction by a base and formation of a carbon-carbon double bond. Because of the mechanism of the reaction, the base doesn't have to be strong. A weak base can do the job, and because of that also, the weak base, not only it can do E1, it can also do SN1. So if a weak base is used, then probably a mixture of SN1 and E1 products are obtained. And because the reaction goes through, or the mechanism goes through a carbocation intermediate, then the rate of the reaction depends only on the concentration of the alkyl halide or the substrate. It's therefore a first order kinetic. It's unimolecular elimination or E1 elimination.